Okay, welcome back. Today we're going to talk about transformations. Well, one of our fun topics that we had in Algebra 1 is coming back again in Algebra 2, and you've seen a little bit in geometry. So it should be somewhat familiar to you and not completely new. But if it is, it's okay. We're going to go through it anyways. So, first off, we're going to start with some generic polynomial f of x. And I'm going to show you in a little bit how to change that into any polynomial, but we're going to just look about the transformations right now. So we're going to start with the generic polynomial f of x. And if we want to translate left and right, you're going to take f of x and you want to affect the x part of it. So we're going to be adding or subtracting with x. Okay, so we're going to either do a plus k or we're going to do a minus k. Okay, where k is how far left or right we are moving. Okay. So if I'm moving left or right, I'm going to either add or subtract in here. Now, with the x, it's opposite the way it appears. So normally we'd say plus would be to the right. This is actually to the left. And this one is to the right. So just remember that the x's are they're weird. They're opposite the way they look. So an example here would be f of x plus 3. This takes our original function, whatever it looks like, and it moves it 3 units to the left. And if I wrote f of x minus 3, this takes our original function, whatever it looks like, and moves it 3 units to the right. Okay, so that's the translations left and right. And the up and down are very similar, but instead of affecting the x, they affect the y. So anything that's going to affect the x will be in these parentheses. Anything that affects the y will be outside. So it's very similar. So here it is outside. Actually, one of these needs to be negative. Oops, let's make this one negative. Okay? And when it's positive, it's going to move it up. And when it's negative, it moves it down. Okay? So outside, it's exactly the way it looks. Positive would normally go up, and it does indeed go up, and negative does indeed go down. So left and right, up and down. These are Algebra 1 review. If you need more help, make sure you ask about it. But x is opposite the way it looks, so the plus goes to the left, the minus goes to the right. The y, the outside one, up and down, is exactly the way it looks. So if I said f of x plus 3, this means up 3. And if I said f of x minus 3, this means down 3. Okay? And then reflections. Reflections are just a negative sign. Anytime you see a negative sign, that's a reflection. And it's just like before. If it's with the x, it's going to be flipping across the x-axis. And if it's with the y, it will flip across the y-axis. And if it's with the outside, it will do the other one. So let's look at f of negative x. Now, what that's meaning we're going to do is we're going to take all the x's and they're going to switch sign. So anything that's over here is going to get mirrored on the other side because the x's are what's switching sign. So anything that's switching sign must go across the y-axis. Okay, so f of negative x is a reflection across the y-axis. Conversely, if we put that negative sign outside, this says all the y's switch. So I have all these y's down here. They're now up here as a reflection. So it's going to be a reflection across the x-axis. Okay, so when the negative's outside, it's a reflection across the x-axis. When the negative is inside, it's a reflection across the y-axis. Okay? And then the last one is dilations, and it's very similar to the reflections, except instead of a negative sign here, we replace it with our trusty k, our constant. Okay, so when k is inside, that means our points are moving left and right. So instead of being a reflection, this is a dilation. So I'd have something that looked like this, and now it's either much wider or it's much narrower, but it got stretched left and right. And conversely, if it's up and down, and it looks something like this, then it got stretched either really narrow or not as narrow. Okay, but it got reflected, it's stretched up and down if it's outside, and left and right if it's inside. Okay, so it's the same principle as it was with the reflections, just you're actually stretching for a dilation. Okay, so quick recap. If you're adding or subtracting, you're going to do a translation. If it's inside with the x, that moves it left and right, opposite signs the way they look. If it is outside, then it's going to be moving it up and down with the same signs the way they look. For a reflection, we're just putting a negative either inside will reflect across the y-axis, and outside will reflect across the x-axis. And lastly, if you put a constant in here and multiply it by x, that's going to do a dilation left and right by that thing. So if I said f of 3x, this is actually going to make it wider by 3, because we're taking all of our points and we're making them 3 wider. And you could make them smaller, just not negative, because a negative is a reflection. And the same thing out here. If I multiplied by a number out here, then it's going to stretch it this way. So a stretch of 3 would make the y's much taller, so you end up with this narrow thing, because you're going to take all the y's and you're going to stretch them vertically. So let's look and see what that looks like in real life. So we're going to be able to put some of this together. So let's say that I have this function, and I need to know what happened to it. Well, we start with our original function. This thing says that I'm going to move it 1 to the left, and this thing says I'm going to reflect it across the x-axis. So you should be able to look at this and tell me that it's moved, it's translated to the left 1, and it's reflected across the x-axis. So no matter how many of these I give you, you should be able to tell me what's going on here. So here I'm taking something and I'm moving it to the left 3. Then I'm multiplying it, so this is a dilation. And since it's inside, this is going to be a horizontal dilation of 2, and it's going to be a reflection across the y-axis, because we're reflecting left and right because it's inside the parentheses. So all of this is going on all at once. So lastly, what you need to understand is what some of this actually means. So let's say that I have f of 2x, and here's my original function. So f of x is equal to x squared plus 2x plus 3. I just made this up. Not all f of x is of this. I just made up some numbers here. But if I want to find f of 2x, what it's saying is I'm going to take whatever x I have here, and I'm replacing it with 2x. So f of 2x will look like this. That x is now 2x plus 2. That x is now 2x plus 3. So I took these two x's, replaced them with 2x, and now I have to do the arithmetic. 2 squared is 4x squared plus 4x plus 3. So f of 2x now looks like this. And here's your new parabola. And it's much wider than the original parabola was. Okay? Same thing happens with negative. So if I have f of negative x, take the original one, and I'm going to put in a negative x anywhere I see a x, and it's absolutely imperative that you have the parentheses here, because negative squared is simply positive. But this negative changes it. So this is our new equation. So this is a reflection across the y-axis, or because it's inside with the x. So whatever you see here, you're just going to plug it in, and that will give you your new polynomial. So it's true for any polynomial. It doesn't matter what it happens to be. I randomly picked this, but you can do it for anything. It can be a cube, it can be a fourth power, anything in the world you want. Just whatever you see in here, you plug it in for x. All right, if you have questions, please make sure you ask, but we're going to spend some class time working on all these.